Hello everyone. Today we will walk through a end-to-end uh, ETL pipeline where we come across and play different roles, kind of from a data engineering perspective, then analyzing the data in the role of a data scientist, and also manif- manipulating the data to drive some of the predictions using machine learning in databricks. So to start with, we use this customer 360 database, and our goal is to predict what are the customer churn, and eventually the goal is once you have predictions, you use this data set to drive your dashboards to further analyze it. This is the very first set of scripts where we are running a custom faker code to generate some of the data sets for us, and from here we can see that the data is kind of normalized, and we are kind of creating three data sets here: orders, users, events. And we intend to follow a medallion architecture where we are collecting data from app events, ERP orders, and users, and some of these have been custom created to simulate a different environments, like getting these events from a Kafka connector, etc., and collecting this data, removing and enforcing some of the cleaning practices to create our silver tables. And from the silver tables, eventually we create the churn features, which will then be used to drive our machine learning practice using MLflow. So churn features is our gold label, gold table. Now we'll walk through some of the standards of the code, where in terms of how Delta Lake helps us with some of the industry standard practices. There's kind of a initial setup which has been done. Now we know that our events are stored in the raw branch layer here, and we're kind of trying to print them out in terms of the CSV files which we had generated. Here we are reviewing what kind of data is present here from the JSON structure of the files, and here are some of the custom data set uh, with address, age group, channel, and churn. This is where we have some labels here to represent the past data, which will later be useful in our machine learning models, with country, creation date, email, first name, gender, ID, and last activity date, along with last name. So this is how our raw data looks like. We also have events view. So we are creating an events view so that we can run our SQL queries in this particular notebook. And events in particular are also representing kind of action view, in which platform they try to view it, along with the session ID and the URL. Databricks has a nice feature called autoloader, which uses cloud files to monitor which whenever new files are created, so that it can incrementally load new data. This is how, where we are reading using the cloud files format data from our delta tables using the table which is provided here. So this is a custom function which has been created, and we are passing the orders, events, users, along with the format and the table on the location where it is present. Once the process is completed, we can then run select star from churn users branch table to see our data populated. The next step is to run the silver data where we are reading the stream from the branch and collecting and transforming a few data along with dropping a few columns which may not be needed. And similarly, we are doing it for the orders data. The third part is to aggregate and join the data to create our ML features. Here we are creating a table based on the previous tables which we just created and join them and combine them up from churn users to order stats and event stats using the user ID. There are some benefits of the delta table which are shown here, like going back in history, seeing what modifications have been made, along with just a parameter called version as of one, which allows you to see the data at any point in time, enabling you to also restore the table to a particular version when needed. It also allows us to optimize different tables for write and to compact the data which is already present through the optimized write and auto compact features. Along with that, it also allows us to order the data so that columns which are frequently queried and used together are stored in similar co-location so that finding them is easier in terms of how we order them in the disk. Once this is done, as you can see, this whole notebook has been run and it is a practice to run it interactively as I've done here. In real world, we would like to run this similar script but more in a pipeline. This is where delta live tables come into picture. Delta live table workflow pipelines can be either written in Python or in SQL. They are very similar to a standard notebook. The only difference is we are importing the DLT package here, and for every function, if you see, we had previously defined the churn app events. The only difference now is that we are defining and annotating it with the at DLT with the create table and the expect in terms of what is the output of this table should be, giving us different checkpoints where we can enable error handling. Now if you see this also enables us to see from an ordering perspective what is the dependency, because when you are running churn users in particular here, if you see dlt.read stream churn users branch, and this is where it knows it has to read from this step first, from this function method name, and there is a sequence which is established here. Now the practice is not to run this from the setup here using run all, but more to run it from a workflows pipeline where you can see it on the left here in the pipelines menu. Here I've already run and I will show you one particular workflow which I have created. We can give the pipeline any name, along with you can either use serverless or use custom instances. Here it can be triggered or continuous. Continuous helps you to monitor it uh, on an ongoing basis incrementally. For this particular setup, I'm setting it to triggered here. You can always set a budget so that you can monitor it. Source code is where the notebook which I did show just now was present. So you can click here and select that particular notebook. This is how workflow pipelines know which Delta Live table notebook to run and associate with. The destination is whenever you're querying, if you saw the function they're trying to query from a particular table name, and this is where it tries to associate in which catalog and schema it needs to search that particular table. There's a schema which I have created and is empty in the default catalog which is main here, and then it is saved. Once it is saved, we can just run it from the start button here. Let's give it some time and we can see how the workflow executes. If you say, it gives us very good messages in terms of in which step it is running. Now the basic setup completed, you can see it starts running the different steps in the DLT workflow pipeline which we had visited previous to this. It's trying to run from different queries and associate this data, establishing the lineage as to from which source tables these different tables have been created from. It will stop once the churn features table has been created. Now you see the complete flow from left to right in terms of the parallelism and the association in terms of how the tables are created. At any point you can you can click on a particular block here and you can see which table it is associated with. So it will take you to the particular catalog, schema, table name, and which source code was responsible for it. After this, the next step is to this can also be run through SQL. Once we have a final data set, we can now proceed on to using and running a machine learning flow. ML flow is the open source component which is associated with databricks in terms of managing, tracking your code, data, results, along with creating projects, registering your models in the model registry, creating models, and also serving your models, which is in preview right now. Here we'll be doing two steps. Once we have a delta lake, which was in the previous step, We now run through creation of a model and associated through ML flow the different artifacts, and finally we run the model to predict the churn for new data and finally deploy it. I'll try to change the database which we had created in a previous one and run all these steps here. So the very first step, it's saying it's associating the database catalog which needs to be used in this particular notebook. Then display the churn features which we had created through the previous workflow pipeline. Showcase some of the plots to show the relationship and explore some of the data and do analysis. So you can see how some of the data sets are dependent and correlated in terms of comparing them to see what is the dependency between them. Once this is established and understood from a data science perspective, we then use pandas to further explore the data and remove some of the missing values, describe the data so that we understand it. And here if you see, we are removing some of these columns because they were not valuable in terms of how they are correlated to the final output, which is the churn data. Here we'll be using the feature store feature available to Databricks, which enables usage of a single data source in the future, both for your training and for inference. Now we are doing converting it to pandas and doing a training and test split, putting a random state of 42 so that it can be reproducible when we run it again, and putting a 30% for test size. Now here if you see, we are selecting the different columns which we can use as training parameters using the sklearn library to create a pipeline where first we convert some of the data sets to numeric and also do imputers so that missing data sets can be filled in, and finally we standardize it so that the different scales of inputs are standardized so that the machine learning model is not biased towards the scale of data. The next step is to convert from string to numeric using one-hot encoder for different categories so that we have in the numerical format different data sets which are understandable from the machine learning perspective. This is how our training dataset seems to be. Now we are removing the churn column from the train data because that is not relevant and we don't want a machine learning model to have insight into it, and rather it should be in the test data for the final output, because that is what we are going to compare against. If you see here, we are starting the ML flow that started because it acts like the metadata store for us. And within this, all of the different parameters will be captured. If you see ML flow SQL autolog, this will capture various metrics by default like samples, metrics, parameters, and models. Finally, we are running the model.fit with xtrain and ytrain parameters passed to it, and also we evaluate it using the pyfunc model, passing in the test data, targets, and the classify model type, giving what should be a metric for the evaluation, which is this information which is passed here. Once this is completed, we can click at this location and view the results of our particular model experiment which we just ran. So here you can see different parameters, the test score, training score, along with different model metrics which MLflow captures for us. It also captures which machine learning notebook was responsible for this particular flow or run, so that we have kind of a lineage and establish to recreate the same results for backtracking. Once this is established, we register our model in the model registry in this particular path. And finally we wait for it to be in the ready state. Now that this has been established, we'll use a model to predict churn for us for new data. Here I'll change one basic parameter, which is the table which we had created, and then run all. So if you see here, we are requesting the registry to give us the model which we had previously registered, and once that is done, we are calling the predict churn UDF here, which calls the model URI and passes the Spark context. If you see here, we are running the predict churn UDF function against the model features, and this calculates a prediction for us. Using this prediction, we are creating a new column called churn prediction so that we can associate this new data column with the previous churn features table, so that there is an association of the churn prediction results in the same features table. This is how the result set looks now. See, with the churn prediction column present here. The next step in the end-to-end flow, where first we data engineered, then using data science and machine learning, we analyzed the data, created a model to predict our churn, and finally registered the model so that it can be served. Using the served model, we then predicted using new data set to have those features established along with existing data features. The final step is to create reporting based on the new results which we are seeing using the dashboarding feature in Databricks. This is a step which I'll leave for you all to explore it out. Hope this session was helpful in terms of seeing an end-to-end flow and understanding where different Databricks features are really helpful to get started with. Thank you.